Welcome to aminacademy.com. In astronomy, let us discuss about the birth of modern astronomy. Astronomy made no major advances in strife tone of medieval Europe. The birth and expansion of Islam after the 17th century led to a flowering of Arabic and Jewish cultures that preserved, translated, and added to many of the astronomical ideas of the Greeks. Many of the names of the brightest stars, for example, are today taken from the Arabic as are such astronomical terms as zenith. As European culture began to emerge from its long dark age, trading with the Arab countries led to a rediscovery of ancient texts such as Almagest and to a reawakening of interest in astronomical questions. This time of rebirth in astronomy was embodied in the great work of Copernicus. The Copernicus. Nicolaus Copernicus, a Polish church official, launched a modern astronomy by proposing a heliocentric, that is, sun-centered model of the solar system. His model still assumed circular orbit, so the ability to predict planet motion was little better than in the Ptolemaic system. Copernicus described his ideas in detail in his book of astronomy, published in 1543, the year of his death. By this time, the old Ptolemaic system needed significant adjustment to predict the positions of the planets correctly. Copernicus wanted to develop an improved theory from which to calculate planetary positions, but in doing so, he was himself not free of all traditional prejudices. Copernicus argued that the apparent motion of the sun about Earth during the course of a year could be represented equally well by a motion of Earth about the sun. He also reasoned that the apparent rotation of the celestial sphere could be explained by assuming that Earth rotates while the celestial sphere is stationary. To the objection that if Earth rotates about an axis, it would fly into pieces. Copernicus answered that if some motion would tear Earth apart, the still faster motion of the much longer celestial sphere required by the geocentric hypothesis would be even more devastating. Now we'll discuss about heliocentric model. A heliocentric system is one in which the planets revolve around a fixed sun. Thus, Mercury, Venus, the Earth, Mars, Jupiter, and Saturn all revolve around the sun. The moon is the only celestial sphere in this system which revolves around the Earth and together with it around the sun. The most important idea in Copernicus' book, that planets that revolve about the sun. Using this concept, he was able to work out the correct general picture of the solar system. He placed the planet starting nearest the sun in the correct order: Mercury, Venus, Earth, Mars, Jupiter, and Saturn. Further, he deduced that the nearer a planet is to the sun, the greater is orbital speed. With planets nearer to the sun have the greater orbital speed. With his theory, he was able to explain the complex retrograde motion of the planets without epicycles and to work out a roughly correct scale for the solar system. Copernicus could not prove the Earth revolves about the sun. In fact, with some adjustments, the old Ptolemaic system could have accounted as well for the motion of the planet in the sky. But Copernicus pointed out that the Ptolemaic cosmology was clumsy and lacking the beauty of symmetry of its successor. Now, next we talk about Brahe, Kepler, Galileo and Newton, the birth of modern science in astronomy. They made very careful measurements of star and planet positions, rejected the Copernican model because he could detect no parallax among the fixed star, and rejected the Ptolemaic model because of its poor ability to predict planet location. Proposed a new complex model with the sun and moon revolving around the earth and other planets revolving around the sun. Now we'll talk about one by one. First, Johannes Kepler studied the data of Tycho Brahe had carefully and collected on planetary motion. Realized that planets move an elliptic, not perfect circle. Supported a heliocentric Copernican, not geocentric view. Showed that the planets change speed during their orbits. That means faster when close to the sun, slower when far from the sun. Next, Galileo Galilei, who born 99 years after Copernicus' death. The Galileo was first person to turn a telescope on the sky. Is the first person used telescope to investigate the sky. Was first to see moon of Jupiter, sunspot, mountain on the moon, phases of Venus, stars in the Milky Way, rings around the Saturn. Proved that Earth could not possibly be the center of the universe, thus supporting Copernican system. Next, Isaac Newton, a great scientist, born the same year of Galileo died. He studied the work of Galileo, Kepler and apple trees, figured out the law of optics, gravity and calculus, came up with the physics to explain Kepler's law, realized the mass and distance were both important in law of gravity and derived a fact mathematically. Now further about Kepler's law of planetary orbits. First law, orbits of planets are ellipses with the sun at one focus. Second one, the area of swept out by a planet in its orbit around the sun is always the same in a given time interval. That means planets move faster when closer to the sun. That is, p square is equal to a cube. Better we can keep it, p square is proportional to a cube, where p is orbital period, that is years, and a is the distance from the sun. Newton's law of motion, we know that. Law of inertia, a body remains at rest or moving in a straight line unless acted upon by some external forces. F equal to ma, second law, the force F applied to a body with mass m will cause it to accelerate, that is change the speed and direction at rate, that is a, acceleration. Action and reaction, every force of or action applied by one body on a second body result in an equivalent but opposite force or action by that second body back on the first body. This useful for deriving Newton's law of gravity, is more useful in astronomy, Newton's law of gravity, since the moon travels in an orbit around the earth and thus not in a straight line. Newton's first law requires that some force must act upon the moon. Newton's insight, this force is the same one that pulls object to the ground on the earth, that is gravitational force. Newton determined a quantitative relationship for a gravitational force between two masses m1 and m2 separated by distance r. Therefore, force of gravity is equal to g into mass 1 into mass 2 divided by separation square, that is Gma/mb over r squared ab, where g is the number, the gravitational constant, universal gravitational constant. If you measure mass in kilogram, separation in meters, and force in Newton, then G equal 6.67 in 10 raised to minus 11. Any two masses attract one another gravitationally, each one according to the third law, exerting an equal attractive force on the other. That is, the greater in masses, the greater the force. The smaller the separation, greater the force. That means in between two masses, distance is less means more attraction. Distance is more means less attraction between two masses. This law provides the physical explanation for Kepler observations. Next, Muslim astronomers of the Golden Period made many improvements to instruments already in use before their time, such as adding new scales or details, celestial globes and armillary spheres, astrolabes, mechanical calendar, sundials, quadrants, and equatoria. So far, we discussed some points about birth of modern astronomy. We have done. Please subscribe our YouTube channel.